Last episode, the checkpointer let an agent survive a crash and resume exactly where it stopped. But a saved checkpoint isn't only a recovery point, it's a point in time you can travel back to. Today, you pause an agent for a human, rewind to before that decision, edit it, and replay a whole alternate branch deterministically. A checkpointer doesn't just save the latest state, it saves one snapshot per step, plan, approval, action, each tagged with a checkpoint ID. That history is a line you can walk backward as easily as forward. At the approval node, the graph calls interrupt. Execution freezes mid-run and hands control to you. The human supplies a decision. The graph resumes from exactly that frozen point. No replay of the earlier steps, no lost state. Now the time travel move. You pick the checkpoint that exists after plan but before approval, and you resume it with a different human decision. The graph doesn't overwrite the first run, it forks, one route, two futures. The chosen branch approved plan B and computed 12 times 12. The alternate edited the decision to plan A and computed 12 plus 12. Two branches, two answers, both reproduced from the same checkpoint ID. History you can rerun. Here's the program. One state graph, plan, then a human approval node that calls interrupt, then act, which runs the scripted calc tool. And in-memory saver gives every step a checkpoint ID. We run the graph on thread main. It plans, then hits interrupt and stops. The trace records a pause, not a finish. We read the interrupt and resume with commands supplying the approval B. Resumed, the act node fires the model's one scripted tool call, calc of 12 times 12, and the graph reaches stop with answer 144. 3 checkpoints are now on thread main. Time travel. We grab the checkpoint written right after plan and edit the human decision to A, replaying from that exact point. Same history route, different fork. The alternate branch runs calc of 12 plus 12 and stops at 24. Neither run touch the other. Both are full, independent histories sharing one fork point. Run the terminal. You see the main branch land on 144, the alt branch on 24, the fork checkpoint shared, and reproduce, confirming both threads, replay byte identical. The honesty caption holds. Only the model's words are scripted. Every step is a checkpoint, so an agent's run is editable history. Rewind, change one decision, replay a new branch, and prove it. Next episode, when a step goes wrong, how a cycle counter caps the retries, so recovery never loops forever.